Dear all, today we are going to learn about elementary continuous time signals. So, what do you mean by elementary signals is that these are the basic signals from which we can derive different types of signals. Okay, so first and foremost, basic signal is a unit step signal. So, if you are watching, unit step signal means it is a signal that can be defined as u of t that is equal to 1 for t greater than or equal to 0 and 0 for t less than 0. That means if I am plotting if I am taking my xy plane, and we know that the independent variable is taken along x-axis and dependent variable is taken along y-axis. So u of t, in the sense that u is the dependent variable and t is the independent variable. So if I am drawing this equation for t greater than or equal to 0 means for t positive, there you are having a continuous amplitude 1, and for a t less than 0 you are having an amplitude is equal to 0. That means this is the signal that you are getting. The amplitude is continuously varying, not continuously varying, it is maintaining its constant value 1 from 0 to infinity, t from 0 to infinity, and it is equal to 0 from minus infinity to 0. So this is actually the unit step signal. Okay, now what do you mean by u of t minus a is that I can define u of t minus a as equal to, it is actually 1 for t greater than or equal to 0. That means this equation, it is actually 1 for t greater than or equal to 0 and 0 for t less than 0. Okay, or if it u of t plus a means it is 1 for t greater than or equal to minus a and 0 for t less than minus a. So what is the meaning is that u of t minus a, the figure is given by this. You will be having the amplitude 1 starting from t is equal to a. U of t plus a means you will be having an amplitude is equal to 1 starting from t equal to minus a. Okay, so this is actually the positively shifted signal and this is the negatively shifted, or this one is the uh, light, right shifted version of x of u of t. Okay, so this is a right shifted version of u of t, and this is the left shifted version of what? U of t. Okay, so right shifted version means represent as u of t minus a, and left shifted means it is u of t plus a. Okay, so this is actually what the left shifted one and this is the right shifted one. So this is actually the known as a unit step signal. That is a one of the fundamental signal, most fundamental signal that is available in signal processing theory. Okay, now you have the second signal. Actually, the second signal is a unit ramp signal. Unit ramp signal means here unit ramp signal is defined as r of t is equal to t for t greater than or equal to 0. That means if t is taking positive values, then r of t is taking the value of t. If t is a negative value, then r of t is taking the value 0. Okay, that means if t is positive, then what? The r of t is taking the value that is equal to t. What is the meaning is that if t is equal to say 4, then the amplitude of that r of t is also 4. Okay, that means r of t is taking the value t. So what will be the angle between the line is, angle between the line is 45 degree. Okay, so ramp signal is making 45 degree with the positive x-axis or the time axis. So this is actually ramp signal. Hmm. Now I can write this as, this r of t is equal to what? Equal to t for t greater than or equal to 0. So I can write it as 1 into t for t greater than or equal to 0 and 0 into t for t less than 0. So what is the meaning of this is actually unit step signal is what? 1 for t greater than or equal to 0 and 0 for t less than 0. If I am multiplying that unit step signal with t, I am getting this r of t. That means r of t is equal to t into u of t. Okay, so ramp function is can be obtained by multiplying what? Unit step signal to an integrator. Okay, oh sorry, multiplying unit step signal with t, or I can say it as, if r of t is equal to t into ut, the r of t can be obtained by applying unit step function to an integrator. For example, if I am integrating this function, what happens? If I am integrating u of t E of t is equal to 1 for t greater than or equal to 0 and 0 for t less than 0. So if I'm integrating u of t, what is happening is I will be having the t axis varying from minus infinity to infinity. If I'm taking the value corresponding to u of t dt, that will be equal to integral 0 to infinity 1 into dt, because u of t is defined for positive values of t, it is equal to 1, for negative values it is equal to 0. So this integral changes to what, 0 to infinity 1 dt, that means 0 to infinity dt, that changes to t for t greater than or equal to 0, 0 for what, t less than 0, that means what, r of t is integral of ut, or in other words I can say u of t is equal to differential of r of t. Okay, so this is the relation between u of t and r of t, or unit step signal and unit ramp signal. Now you have the third signal, that is known as a unit parabolic signal. So unit parabolic signal is defined by using this expression: p of t is equal to t square by 2 for t greater than or equal to 0 and 0 for t less than or equal to 0. Or I can say how I can write this particular thing is, I can write this p of t is equal to 1 into t square by 2 for t greater than or equal to 0, or 0 into t square by 2 for t less than 0. Okay, so if I am multiplying t square by 2 with 1, I am getting it as t square by 2. If I am multiplying t square by 2 with 0, I am getting it as 0. So what is this? This is actually what, t square by 2 into u of t. So I can write p of t is equal to t square by 2 into u of t. The another relation is, the unit parabolic function can be obtained by integrating the ramp signal. So you know that ramp signal is what, r of t is equal to t for t greater than or equal to 0, otherwise it is equal to 0. Okay, so if I'm integrating r of t, if I'm integrating r of t dt, the integral is over t, that is varying from minus infinity to infinity. If I'm integrating this will be changing to what, 0 to infinity t into dt, since r of t is having amplitude equal to 0 for t less than 0. If I'm integrating this, I will be getting what, t square by 2. So that is that means I can define p of t is equal to integral of rt dt, that is integral from 0 to infinity t dt equal to t square by 2 for t greater than or equal to 0. If p of t is integral of r of t, then r of t will be differential of p of t. Okay, then you have the another signal, that is a most important signal in signal processing theory, that is a unit ramp signal, unit impulse signal. So what is a unit impulse signal? So unit impulse signal means it is a function which is satisfying the condition integral over t from minus infinity to infinity del of t dt is equal to 1. So what is the meaning of the statement integral t from t, that is varying from minus infinity to t x of t dt? This quantity is actually area under the curve, right? This is the area under the curve x of t, area under the curve formed by x of t. So actually, what is the meaning of this statement is that area under the curve is equal to 1. Okay, so if you have a function del of t, the area under the curve is equal to 1, indicates that that is an impulse function. So impulse function is satisfying the what? Satisfying the condition the area under the curve is equal to 1, and it is equal to 0 for t greater not equal to 0. Okay, so two conditions are there. If you are taking the full range of t from minus to infinity, the area under the curve formed by impulse function is equal to 1, and del of t is equal to 0 for t not equal to 0. So how I can define the signal is that you will be having a signal like this. Okay, assume that you will be having a signal like this. You need to make the area under the curve is equal to 0. That means if you are taking the interval from 0 to delta, the width of this particular portion is delta. So in order to make the area under the curve is equal to 1, my height will be what? It should be 1 by delta. So I can take the area is equal to delta into 1 by delta, that is equal to 1. Okay, so I'm getting this particular signal. Then what happens if I'm decreasing this delta? That means if I'm decreasing this delta, the width will decrease. Okay, the width will decrease and the height should what? It should increase. Okay, that means if I'm decreasing the area, decreasing the width continuously, I will be getting a very thin line. thin line that is most close to y-axis, and it is moving towards infinity because my area delta is what? Delta is tending to 0. If delta is tending to 0, 1 by delta will be tending to infinity. Okay, if that is the case, that signal for delta approximately equal to 0 is known as what? Is known as the delta t or impulse function. Okay, so impulse function is actually originated from a rectangular signal that is having a width of delta and height of 1 by delta. As delta tending to 0, I will be getting the amplitude 1 by delta is equal to infinity. And in order to, then at that time also area under the curve will be equal to 0. That signal is known as the unit impulse function. Okay, so that is the theory behind unit impulse function. Unit impulse function means area under the curve is equal to 0, and it is not defined for what? It is not defined for t not equal to 0. It is not defined in the sense that for t not equal to 0, it is equal to 0. Otherwise, it is having an amplitude and area under the curve is equal to 0. So, that is the thing here it is explained. I can write u of t. If I am taking it u of t, this is my u of t. You know that the previous class we study about u of t equal to this for t greater than or equal to 0. Okay, now suppose that I am taking u of t minus a. Okay, if I am taking t minus a, I know that t minus a is starting from positive a, since here you have a minus sign. Now if I am taking the sum of these two, sorry, difference between these two signals, that means I am taking u of t minus of u of t minus a or t minus delta, let it be delta t minus delta. Then what is happening is from 0 to delta. From 0 to delta, I am having an amplitude of 1 here and 0 here. Okay, so my amplitude will be what? 1. 1 minus 0 is 1. But from delta onwards, what happens is here the amplitude is 1, here also the amplitude is 1. 1 minus 1 is equal to what? 0. That means I am getting a signal that is varying from 0 to delta. Okay, then if I'm here the amplitude is 1, right? If I'm multiplying it with 1 by delta, I will be getting a signal like this. So that is why it is indicated like this. Now what is delta is limit delta tending to 0, 1 by delta into u of t minus u of t minus delta. Okay, that means the area under the, in order to make the area under the curve 1, and in order to make the width infinitesimally small, I need to make delta what? Tending to 0. Okay, so that is actually del of t. So that is illustrated in this figure. You have u of t minus delta. You are getting this particular signal, and if you are multiplying this with 1 by delta, that means this signal with 1 by delta, I will be getting the limiting case of impulse step function, impulse signal for delta tending to 0. Okay, then this particular signal or delta of t has certain properties. First thing is, also before that you have the unit delayed unit impulse function. Delayed unit impulse function means it is same as the delayed unit step function. Here also the area under the curve is 1, but the thing is for del of t minus a, it is equal to 0 for t not equal to a. That means it is defined only for t is equal to a. Otherwise it is equal. It is having non-zero amplitude only for t equal to a. For all other values of t, it is equal to, or amplitude is equal to 0. The properties are, first property is this: if you are multiplying then a signal with del of t, that means x of t into del of t, and if you are taking the area under the curve of that product, then that will be equal to x of 0. Okay, so how I can do this is, assume that x of t is a continuous time signal. Okay, x of t is a continuous time signal. I am taking x of t at t equal to 0. So x of t at t equal to 0 can be designated as x of 0. Okay, I am multiplying x of t with del of t. So what I am going to do is, here del of t is having a non-zero amplitude only for t equal to 0. For all other values, this will be equal to 0. Del of t is equal to 0. So if I am taking the product, 0 into any quantity will be equal to 0, and what? 1 into any quantity will be equal to 1. So since I am not sure about the amplitude of del of t at t equal to 0, but at t equal to 0, it is having an amplitude. This del of t is having an amplitude. Okay, and for all other values of t, this del of t is equal to 0. So if I am taking the product, that will be equal to what? The only one value I am getting at the output, that is equal to the x value at t equal to 0 into the given function del of t. Okay, so x of t into del of t will be equal to x of 0 into del of t. So if I am substituting in this particular integral, x of t into del of t is x of 0 into del of 0. X of 0 into del of 0 means x of 0 is a constant, the amplitude of x at t equal to 0. So I can take it outside the integral. Then I am getting this integral. Actually, this integral is equal to what? 1. Since the area under the curve of impulse function is equal to 1. So I am getting it as what? X of 0. So that is the first property. Okay, then you have the next property known as the product property. So product property states that the same thing, if I am multiplying any signal with a delayed impulse del of t minus t0, here we know that del of t minus t0 is having amplitude only for what? T is equal to 0. That means it is equal to 0 for t naught equal to t naught. So that means at t equal to t naught, del of t is what? Del of t is not equal to 0. Sorry, here it is equal to 0. So del of t minus t naught is equal to 0 for t naught equal to t naught. So that means at t equal to t naught, del of t is not equal to 0. So if I am taking the product x of t into del of t minus t naught, that will be equal to what? X at t equal to t0 into del of t minus t naught. Okay, so that is a property known as a product property of impulse signal. Now we are moving towards the next property known as a shifting property of unit impulse signal. Shifting property states that if I am multiplying the signal with del of t minus t naught, and if I am taking the integral, then that will be equal to x of t naught. So this property is same as the first property. There you have del of t, here you have del of t minus t naught. Okay, so that is the difference. If t minus t naught is there, then x of t0, x of 0 will be replaced with x of t0. Okay, so I'm explaining here x of t at t equal to t naught is x of t0. Del of t0 is having, t minus t0 is having 0 value for t naught equal to t0. If that is the case, if I'm multiplying these two things, only one product will be existing, that is x of t0 into del of t minus t0. Then x of t0 is a constant, so I can take it outside the integral. Then I am getting the integral. This integral is actually is equal to what? 1, because this is the area under the curve of a shifted impulse signal. Okay, so I can write this particular thing is equal to x of t naught. So this is known as the shifting property of unit impulse signal. Hmm. Now I have the next property known as the time scaling property. Time scaling property states that del of at is equal to 1 by mod a into del of t. Okay, del of at is equal to 1 by mod a into del of t. So here what is the importance of this particular property is that here how I can prove for this is I am taking the signal. I am considering the integral over t from minus into infinity x of t into del of at dt for a greater than 0. Okay, so if I am taking this, suppose that I am multiplying this replacing this at with lambda. That means I am putting at as equal to lambda. If at is equal to lambda, I know that a into del of t will be equal to what? Del of lambda. Or I can replace del of t with lambda by a. Okay, if this is the case, this integral can be written as integral over this particular at, I am going to substitute it as lambda. Therefore, t changes to what? Lambda by a. So, x of t changes to x of lambda by a. Del of at changes to del of lambda. dt changes to d lambda by a. And here lambda is varying from minus infinity to infinity. Okay, now here I have a constant 1 by a at this particular moment. So 1 by a I am taking it outside the integral. So I can write it as 1 by a into del of integral x of lambda by a del of lambda d lambda. Okay, now I know that if I am multiplying a signal with del of lambda, then the product will be equal to what? X of 0 according to the property 1. So this I can write it as what? 1 by a into x of 0. So this integral is now equal to 1 by a into x of 0. Now I am considering this at a equal to minus 2. What is happening? That means if a is a negative quantity, what is happening is that if a is equal to minus 2, if a is equal to minus 2, then I am having this integral as what? The x of t into del of at changes to x of t into del of minus 2t. If I am multiplying this 2t with lambda, I am getting it as what? Del of x of del by 2 into del of minus of lambda by 2. Here also, if I am taking the product, this particular thing will be replaced with x at 0, because here you have del of lambda. Del of lambda will be having non-zero value only at lambda equal to 0. Therefore, here also it can replace it with 1 by 2 into x of 0. So, whatever be the value of a, whatever be the value of a, whether it is positive or negative, here you are getting the magnitude of 1 by a. Okay, so I can write it as what? Integral x of t del of t at is equal to 1 by mod a into x of 0. So that is, consider that as the equation number 1. Now I am going to take the property. Now consider 1 by mod a into x of 0. Okay, so we know that what is x of 0? X of 0 is, can be written as integral x of t into del of t dt according to first property. First property states that integral x of t del of t dt is equal to what? X of 0. So this I can write it like this. Okay, now if this is equal to this, that means 1 by lambda into this. If I am taking this 1 by mod a inside the integral, I can write it as x of t into 1 by mod a into del of t is equal to dt. Okay, so if this is the case, if this is equation 1, if I am taking equation 2, this is equation 2, if I am taking equation 2 and equation 1, the LHS, RHS of equation 2, RHS of 1 is equal to LHS of 2. Okay, RHS of equation 1 is equal to LHS of equation 2. Therefore, what? Therefore, RHS of equation 2 should be equal to what? LHS of equation 1, right? This particular term, that means this particular term should be equal to this term. That means what? Del of AT should be equal to 1 by mod A into del of T. So that is the property. Del of AT is equal to 1 by mod A into del of T. Okay, thank you.